Okay, so I want to continue where I left off before. We're looking for a linear function that's going to model the narrowing of women's and men's wages over time. And so, since we're looking for a linear function, we go back to our basic linear equation, which is y equals mx plus b. Here, we're not working with x, we're working with t as our independent variable. So I swap out the x and put a t in. Next, what I want to do is I want to find the slope of the line, and in order to do that I need 2 points. Well, I have the point at time t equals 0. I know that women's wages are 68% of men's wages, and so I've started to write 0.68 m. M doesn't refer to slope here, m refers to men's wages, so I hope everybody's got that. Okay, so we have that first point there, and 0 is our t value, and 0.68 m is our women's wages value. And it turns out to be 0.68 times 68% of men's wages are 0.68 m. We have another data value 10 years later, and in 2000 women's wages were 80% of men's wages. So we'll write that point as 10, 0.8 m. So now we have these 2 points. We used to say x1, y1. Well, now we have t1 and w1 and t2, w2. Alright, to find the slope of the line passing through those points, we just need to do y2 minus y1 over x2 minus x1. In this case, it's going to be w2 minus w1. I'm not sure if I said that right. w2 minus w1 over t2 minus t1. Alright, so we'll plug in those values. So our w2 is 0.8 m minus w1, which is 0.68 m. And then that's divided by 10 minus 0. So 0.8 m minus 0.68 m is 0.12 m. And that's going to be divided by 10. When I divide 0.12 by 10 on my calculator, I'm going to get 0.012. And that is the slope of my line there. So watch what I'm going to do. Now, instead of calling this y equals, we're going to say this is women's wages. What we're trying to calculate here is w. So I'm going to let that y be w. And the slope is 0.012 m. Don't confuse the two m's there. The first m is the slope of our linear equation. The second m refers to men's wages. I understand that that can be a little complicated, but we're going to have to do it that way. Now, the next thing, though, we multiply the slope times t. And once again, this is where it can get complicated because we have these two variables in there. So it's 0.012 m, which is the slope, times t, plus b. Remember what b is. B is the y-intercept. That's the value of y, or in this case w, women's wages, when time t is equal to 0. And at that point, women's wages are 68% of men's wages. And again, it's kind of crazy because we have a variable in there. We're not used to seeing that variable, but we're going to see in a second how that all goes away. Alright, so this is really the equation that we can use to calculate women's wages with respect to men's wages. We're not going to get a value for women's wages, how much they'll be, but we're going to get the women's wages in comparison to men's wages as a percentage of men's wages. So we'll see that in a second. Now what we're actually looking for here is how close, or women's wages were what percentage of men's wages at the beginning of 2004. Well, 2004 is 14 years after 1990. So t is going to be equal to 14. So I need to multiply 14 times 0.012 m. And remember that multiplication is commutative, so I can multiply the 14 times the 0.012 directly. And when I do that, I'm going to get 0.168 m. And now I have 0.168 m plus 0.68 m, and that gives me 0.848 m. And that means that women's wages would be 84.8% of men's wages in 2004.